So, as as we're moving towards the remainder of this semester, it's important that we lean a little bit more on SPSS. I'm going to introduce you to the hand calculation for ANOVA, but I am not going to ask you to perform these hand calculations. One of the biggest reasons is that as you move forward in your education, as you are, continuing to learn more about statistical analyses, quantitative data, the likelihood of you having to actually calculate things by hand is increasingly smaller as you move further and further through your education. So while it is helpful for you to have the understanding of what it is that's going on behind the scenes of SPSS, for the purposes of our class, I'm not going to be asking you to do any kind of hand calculations. But I still want you to understand what is happening back there. So, just to preface, there are a total of 13 steps for calculating ANOVA. It's kind of another reason I didn't want us to have to do hand calculations. As you can imagine, the more steps that we include, the more likely it becomes that we may make some kind of very even small mathematical error along the way. So please, before I even bring up these steps, I just want to reiterate, I am not asking you to do any hand calculations. For steps 1 through 3 of ANOVA, the first step, as you can imagine, is always identifying your null and research hypotheses. Of course, we would want to make sure that they are contextually appropriate for the research that we're conducting. We wouldn't just say that not all of the, or I'm sorry, for our null hypothesis, we wouldn't simply say all the means are the same, and for our research hypothesis that they are not the same. Again, we want to emphasize that they are, contextually contextually written to speak to our particular research. And I'll make that point again when I discuss a little bit more about the assignment associated, the learning check associated with this, particular chapter. Step 2 would be to find the mean of each group and square raw values. These are things that we've done before, we've experienced before, calculating means, adding up all the scores, dividing by however many there are. This is something that you should feel much more comfortable with by this point in the semester. And we would also square the raw values, another, kind of emphasis here that when it comes to the statistics that we are conducting in this class, we don't ever get more complicated than PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, all right? For step 3, there are a couple sub-steps involved. We would be calculating the sum of X total, where we are taking the sum of each sample of scores, okay? So when we see the sum of X, that's something that we've seen before, where we're adding up all the scores. Remember that these smaller numbers, these subscripts, are intended to now indicate how many groups we're talking about. So this sum of x1 is intended to reference group 1, sum of x2 for group 2, so on and so forth. This sum of xn is, you would just, it's intended to communicate to you that for however many groups you would just continue doing this, right? For how, if you had 4 groups, then you would stop with 4 groups, but if you had 5, 6, 7, so on and so forth, you would continue this process. The sum of x squared total, so we're taking the squared values of our raw scores and then adding them all up. We do this across all of our groups. We calculate what's called the N total, where we are taking the sample size from each group and adding them all together. And then we take the mean total, where we are taking the sum of X total that we calculated in this first substep and dividing it by the N total that we calculated in the third substep. So for ANOVA steps 4 through 8, we would calculate the sum of squares total. So this is kind of that callback to when we were first introduced to sum of squares as part of learning about variance. And so notice that these components here are elements of the sub-steps that we learned about in step 3. Within step 5, we are calculating what's called the sum of squares within groups, where we're taking the sum of x squared total, and then we're we're subtracting it from the sum total of, doing all of these mathematical calculations, where we're taking the n of each group, multiplying by the mean of that group, and then squaring that value, and then you add all those up. Then finally, with the sum of squares between, we have the sum of n group multiplied by the mean group squared minus n total times the mean total squared. So the reason I want to pause here for a moment is notice what's happening with this ANOVA test. We are looking for the sum of squares total. This is the sum of squares that's happening across all of the groups combined. Then we're also looking at the sum of squares within. What is happening within each particular group? And then we're looking at the sum of squares between, where we are looking at what is the interaction that is happening between, each of the groups that we have. And so, like I said, I wanted to pause here to give you an understanding that with this analysis of variance, we are looking at how all of these different components that we're incorporating into this test are interacting with one another. So it becomes very complex, very complicated. Also, another reason why I didn't want us to calculate this by hand, because while it's a little bit more reasonable, we use that loosely, reasonable, to do this if we were working with maybe 3 groups. If we started to incorporate more groups, it just gets more and more complex, right? Not that we couldn't do it, but for where we're headed in this class, I want us to focus and lean a little bit more heavily on SPSS. We would also calculate or determine what's called the degrees of freedom between. We've already learned about degrees of freedom, where, with the degrees of freedom between groups, what's happening between each of our groups. And so we would take the total number of groups and subtract 1. This comment here about the numerator, this would be more applicable if I were going to show you the table associated with ANOVA. And so I'll expand a little bit on that in just a moment. I'm not going to show you the table. I'm going to make it available to you in Canvas, but we won't be using it in this class. For step 8, we would determine the degrees of freedom within, where we're taking our n total minus k. That would be our denominator. Again, the numerator and denominator components of this particular slide are relevant for navigating table D. And I'll comment on that in the last set of steps that we have. So we would also calculate this relatively new piece. It's the mean of squares within, and then the mean of squares between. Then we would calculate the F ratio. I mentioned earlier in this presentation when talking about the t-value that we were going to be introduced to a new statistic called the F ratio, or the F statistic. Now, this new statistic is, remember that our t-distribution uses a t-statistic because we're not working with hypothetical data. We're not working with probability data. And so the idea is that we don't necessarily know that our data is going to be creating that normal distribution for us. And so the t-distribution kind of accounts for not necessarily knowing if our data is going to meet that bell-shaped curve. With the F ratio, it's just doing that same process, but now with the understanding that we are working with more groups. So we have to make those accommodations for the differences between our data, meeting the expectations of being a normal distribution. And then finally, we would use table D to determine the critical F ratio. This is a familiar practice for you. We did this with finding the critical T value. However, with table D, instead of using an alpha level and degrees of freedom, we would use the degrees of freedom between and within from the previous steps as our numerator and denominator. We would still be looking for where those two values intersect, but there are separate tables created for an alpha level of 0.05 versus an alpha level of 0.01, and therefore we wouldn't necessarily we wouldn't be accounting for those intersecting points by looking for the alpha level. So again, I'm not asking you to do that in here. I am going to make those resources available to you. They could be beneficial, moving forward to your next classes. But for what we're doing in here, we won't be using them. And finally, we would still make that comparison, right? So the point that we were coming to with t-tests was calculating a t-ratio, comparing it to a critical t. We still do that same thing here. We calculate an F ratio, compare it to a critical F. We're still looking for the value that is further away from 0 and trying to determine whether or not there is significance in our data. And that's the end of ANOVA, all right? That's the end of ANOVA. Hand calculation, I'm sorry you had to see that. Like I said, it can be very overwhelming when you're first introduced to it, but you all will be hopefully happy to know that we're not doing that in here.